Welcome to the SW booth with my buddy Kurt. A topic we want to discuss today, well actually two of them, is productivity and the labor shortage we have going on right now. And one of the first things I think of when I see that beautiful SW logo is productivity. But I want to discuss this with you to get your perspective and share with the world watching right now.
You know, it's just been so chaotic right now in our business. You know, it doesn't take us very far to go away from McCormick Place to find labor shortage issues, you know, be it at the diner, the supermarket, whatever. We can't find people. So when we get into our high-tech industry of manufacturing, finding the right people with the right skill set becomes that much more challenging, right? So if we look big picture, the whole market, the Gartner survey last year for 2022 capital spending, you know, they're very clear. The number one reason people are buying machines today is to gain better productivity and better efficiency. You know, everybody's getting squeezed on the manpower side of things. People need to make better investments so that when they're purchasing that asset, they're getting more out of it. And that's, I think, a lot of place where SW comes into play. Starting with the fact that our core products are dual or four spindle machines. No doubt we have a single spindle machine right behind me, don't get me wrong, but our core equipment historically has been 2 and 4 spindle machines. So just think about that productivity gain right out of the chute, with rather than cutting with just one tool at a time, going and hitting 2 parts at once. Double the output, or best case scenario, 4 parts at one time. Double or quadruple the output. That just gives you so much savings in regards to your manpower, needing to operate cells of machines that have high volumes. It gives you so much benefit in regards to the efficiency of the floor space that you're using when you have to expand a building. That costs a lot of money. If you don't have enough space within your shop, you have to build another building. It costs a lot of money. So going to the 2 and 4 spindle solutions on SW is a great way to be both more productive as well as more efficient, for sure.
Well, you know, I started this whole thing off with when I think of SW about productivity for the reasons you mentioned, right? And you told me one time when we had an interview about the carpool lane and getting 4 people to the same spot as a single person in that same time frame. And traditionally, you guys have dominated the automotive industry when it comes to that, and automotive industry needs productivity, demands productivity. So you guys are kind of ahead of the game and focusing on these different chapters of how you can support these industries best, right?
I think we're just absolutely well positioned for the time that we're in right now. You know, and it's not just automotive, to be clear. There are a lot of other industries that just haven't caught up to the demands of needing to be more productive, to be more competitive, to be more profitable for the sustainability of their businesses. You know, we have several examples of replacing a dozen, 2 dozen, 3 dozen single spindle machines with a bank of SW machines, and again, saving that manpower demand as well as floor space. So we're well positioned with the change in other industries outside of automotive, for sure. I think the other big benefit that we're bringing to the table is with the change of electrification. We'll speak about it a little bit more. But with all the lightweighting that's going on and the changing from iron and steel components to aluminum as we go to linear motors, that brings in that next level of productivity and speed on the machine tool.
And we're going to talk a bit more about linear motors and automation as well. But I also just kind of wanted to bring up, and you weren't queued up for this, but I think it's a conversation based on how you started. You go into restaurants, you go into places. I mean, half the places can't seat half the people that want to be there because there's no service. Do you guys actually have a growing entrepreneurship, but school system within your facility that educates, so you just continually bring people in and help them grow within SW as well, don't you?
Our apprentice program truly is best in class. That's me saying that. I take a lot of pride in that, but others from outside our organization also view it as being great successful. And you're spot on, right? You got to grow your own talent organically from within. It's a great solution for the company. We need those resources. We just graduated our first 2, Nico and Max, going into operations and building our assembly. Max is actually going to be our team leader for building our automation solutions in our shop. These guys have done a great job through their 3 years in school and apprentice program, and Nico's going into the service side. And we got to find service guys more than any other position within our company. So to have taken these kids and having been patient for 3 years to now bring them into very productive and very necessary roles within the company has been just game-changing for us. And we've got 2 more behind them and 4 more after them, and we just look to grow this program all the more.
That's absolutely perfect. And I know we want to get more into the automation side of things. I know Joe and Peter are excited to talk about the automation side of things. For just to close this out before we send it over to Joe and Peter, if you're one of those young guys out there, or even an older guy that's looking for a career change and you want to jump into this apprenticeship program, SW is a great company. Kurt, really great start to this live stream. Now let's send it over to Joe and Peter and see what they have to talk about when it comes to automation.
Thanks, Tony. So I'm here with Peter. Peter, many thanks. This is one of the highlights of the show for me, this machine tool, the BA322i. What does it mean?
It's a dual spindle horizontal machining center that has actually two tables. So you have one table here in front of the operator, already automation, and then it has another table in the back. So that allows you to do two operations in the same machine. And either operation could be 4 or 5 axes.
And looking at this, obviously they're two of the same parts, but it's twin spindle and it's a rotary table, so presumably you can have op 10, op 20 work.
Yes, so you can do 2 operations on this machine with the AB load, in this case handled by the robot here. And either of those 2 operations can be either 4 or 5 axes. So you have 100% flexibility there, yeah.
So if you're watching this and you're interested, if you've got any questions, please do let us know. But if we keep talking about this, just tell us how this automation system would work.
Yeah, so it's really neat. It's a really compact machine, and the automation, as you can see, only builds a couple of feet out here. And it uses a tray-based system, so it's appropriate for parts that are on trays. And behind here is a stack of trays that are loaded on the back side of the machine. And then the robot will pull out these trays into its reach, and from there he's inverted so he can service the machine. So he can load the machine, and he can also handle the A and B load between the 2 operations. You can also incorporate smaller things like a pin stamper or a quick camera check or something that would fit inside of this envelope.
And if we look at this, it's almost 2 machines in one, isn't it? When you look at this, we're making 2 parts instead of 1. It's highly automated. So it's basically getting 2 machines in one, automated on obviously the footprint of 1 machine.
Right. It's really efficient because you run the 1 machining process and you get two pieces out at the end of the day. And if you look at the footprint of what you got going on here, you can really do a lot more volume in your plant when you have use the dual spindle machine versus a bank of single spindle machines would take up a whole heck of a lot more floor space. So what happens at the end of the day, cost per part goes down.
Yeah, and when we look at this machine, we can tell obviously the parts are coming off potentially complete with the op 10 and op 20. But how about other things like such as inspection, maybe part marking, things like this?
Yeah, so if you want to inspect the parts within right after you machine them, just to guarantee you're not making any bad parts, we would have to take it a level up from what you see here. This is very compact, very cost effective, but we would go to a floor-based robot cell. In this case, we can have 2 machines facing each other for a cell for 4 spindles, and we can incorporate a different style here for load and unload. The robot will be on the floor, and we can then have CMMs there. Either we can have 1 floor, shop floor grade CMM, or we can have 2 comparators, like similar to the Equator or something like that. We also recently finished a cell that has also a laser marker in the middle. So you pack quite a punch in compact footprint.
For sure, and that, what you're describing, we often see in CNC machine shops in their showrooms, but you actually sell this, don't you? You do actually have customers doing what you've just said.
Oh yeah, we have I think 4 or 5 programs we're executing right now for parts similar to this from only our US operations. So the demand for automation is huge. And it all stems from that the manufacturers, they have really trouble finding labor, and the automation, doesn't take vacation, and it's very consistent. So once you start it off, it does the same thing all the time. So the output's very consistent. This is why you want to, for instance, do measuring in the same cell, so you cannot secure that you get a good part coming out.
Okay, a big thank you to Mark Mendoza on LinkedIn, who said, great machine. Maybe you should buy one, Mark, if you like it that much. But yeah, just coming back to the machine, going back to the machine, you know, it's what happens if my parts are much larger? Obviously, this will have a maximum payload. The machine tool itself will have a maximum size billet you can fit within it. So where does the range go from here?
Yeah, so we have a slew of other solutions we can put in. We have a very big range of different machining centers in terms of size. So we have a platform we put in front of the machine with an overhead upright robot that reaches down together with a high storage system. So that's a nice solution. Or we also have overhead gantry systems that reaches down into the machines. And with those, we can really achieve really nice solutions for a bank of dual spindle machines.
You've got a large component on the SW08 as well, so could potentially that be automated?
Oh yeah, absolutely. We can do parts like that. We can do bigger parts than that. The overhead rail-mounted robot works really well because it has full flexibility in terms of manipulating the part. So a lot of times you have to kind of wiggle it into your machine fixture, and that's not so easy to do with a more linear motion platform.
Sure. We've had a comment about the machine tool itself, so perhaps we can have a quick look over here. So, like you say, twin spindles, looking to basically getting two parts for the price of one.
Yes. Yeah. You have the two spindles moving in unison, cutting two parts at the same time.
And you have to ask, you know, potentially, do I need tens, hundreds of thousands of the same component, or is that a myth? Can you do this on fairly low volumes?
Absolutely. It all depends on the machining time of the part, right? So if it's a long processing time for a part, you don't need that big of a volume to justify the dual spindle machine. And if you run families of parts, for instance, hydraulic manifolds, there are families of parts that are made out of the same raw component or raw part, but there's a lot of similarities between the different ports, for instance, for a part like that. So then allows you to run families of parts in the same machine. So then the volume can really vary and be anything from low to medium, and it will still be a viable solution.
Yeah, and when we look at the CNC control, you know, engineering companies are are struggling to find labour nowadays, aren't they? Hence automation, I guess. But in terms of the CNC control itself, how easy is it to program two spindles instead of one? Does it literally, you program one and the machine knows to do both spindles? Yes,
yeah, you program one program, and on this machine you would run one program. We have other larger machines where we have independent Z-axis where we can do some more tricks, but really it is not more difficult or anything like that. You have to be a little bit more mindful to make sure that you set your tools right, because it's a dual spindle machine. And once you got that under control and combined with our expertise in fixture design for two spindle machines, you really have you don't have to worry about it. There's a lot of fear out in the industry, but it's really not justified. At the end of the day, you get a lower cost per part, and that's what you need to keep some of these parts stateside, right?
So I guess spreadsheets sell these machines, it's down to mathematics.
It's down to mathematics, yeah.
There we are. So, lovely machine. You're getting two parts instead of one on a really, really small footprint. And I know Tony can't wait to get back on this live stream, so let's head straight back to Tony.
And now we are live back again with my buddy Kurt, and we're going to talk about the benefits of linear motors. Kurt, linear motors, my friend, so many benefits, aren't there?
So, you know, linear motors, it's not necessarily new technology. Maybe had a little bit of a black eye if you go back 25, 30 years ago. But for us, it's been, you know, half of our offering since the early 2000s. Linear motors, what's so interesting about linear motors? Number one, they're super wicked fast, right? You know, probably double the speed of ball screws, 120 meters per minute. You know, you're going to have some fast ball screw machines out there, but generally you're twice as fast. That means when you get into these processes with 15, 20, 40, 50 tools, and you have all the tool changes, you know, moving from point A to point B, all that non-value added time in your machine, we're twice as fast. So when you get into that production environment where you do require multiple machines, multiple spindles, there's a very good chance that simply switching to linear motors from ball screw is going to save you a machine. If you save yourself a machine, you're saving yourself a ton of money. You're saving yourself a ton of money, you're more efficient with your dollars, more efficient with your productivity. It's just simply a better solution. So speed, acceleration, reduction of parasitic time, it's just a great solution.
And let's not forget that maintenance that you mentioned to me as well. These things are going to run for, I mean, you tell me, they're going to run a long time.
So obviously when I speak about a linear motor, I've got a primary and I've got a magnet, right? That's my drive system and that's my motor source, compared to a ball screw system where you got a motor, the ball screw, and the ball nuts. Well, in the ball screw and the ball nut, obviously you have the mechanical connection between the two. And to be clear, half the machines we sell are ball screws, right? If we're running steel or iron, we're going to run ball screws, right? But if you have the opportunity with the non-ferrous materials to run linear motors, you really should. So to the maintenance point, to kind of put a pin in it, we sell spare parts. It's part of our business. Imagine that. For every linear motor that we sell 25 ball screws. 25 ball screws. So if you do have the opportunity to run linear motors and you want to reduce your maintenance cost, let's talk about the benefits there. So it means you don't have that unplanned failure of a ball screw in the middle of a work week. You don't have that scheduled maintenance to replace a ball screw in the weekend. And this ultimately all comes back to manpower. If you have a machine that doesn't have these mechanically rotating parts, that means your maintenance team potentially could be smaller if you're an all aluminum plant. And it goes back to the speed and dual spindle, quad spindle, means you have less manpower on the operation side and again on the maintenance side. So we've really done great things in the aluminum side. Speaking of this machine right here, we're cutting a dummy part, which is similar to this hybrid battery tray, which is a die cast component. It has a lot of machining on it. It's only single spindle, but we are still whipping around really significantly. So with the transition in our automotive business to electrification, electrified vehicles, we're very well positioned. It's not just the battery trays themselves, but it's also the components around the machine, be it a knuckle, a control arm, whatever. There's so much focus on lightweighting these vehicles to be more efficient and get higher range. The change from steel and iron components to that of aluminum is changing significantly. And die casting technology is changing as well. We all hear about the GigaCast solution from Tesla. It's a huge, huge machine that they have. And now this creates the possibility for the engine cradles and the rear systems to be truly die cast. And this, again, plays directly into the SW solution with linear motors.
Well, Kurt, I know you're a clever guy, which is why you were able to bring this whole thing full circle, right? Labor shortage and productivity, over to automation, then talking about the speed and reliability of linear motors. We're about to close this thing out, but I'm looking at this beautiful piece on the wall over here. Can we get one of our camera guys to take a look at that piece on the wall over there, and you could describe what's going on?
So what we've got is a Daimler battery tray. It's for their EQS platform. And that is an assembly for a full EV vehicle. Starts with 27 components, I believe. So all of the individual components prior to assembly are going through this very same machine, W812 single spindle. And then we pass it through assembly, not from our side. And then we bring it back to our space machine. So it's just a really good example of how linear motors on aluminum components are really changing the speed and the output and the productivity of these types of components in this market.
Very, very well said. So now that you've inspired all the people around the show that are watching you live right now, how good are you at this? Let them know what booth you're on. Let them know, to come see you.
Booth 88140.
I love it. I love it. Well, sometimes that's what happens.
Just find us in your show planner.
There's a beautiful SWB Smart sign around us. It's easy to find. Come see my buddy Kurt, talk about productivity, showcase why you're having an issue at your facility. They'll help you solve those problems. Agreed, Kurt?
Bring it on. We love to find those solutions. We got the smart manufacturing solutions with the machine and the automation. We'll make it work.
And with that being said, thank you all for watching. This is Edit SW, productivity, automation, linear. It's everything in one place. Come take a look. Thank you all for watching.